AC75 is a revolutionary new concept, an America's Cup monohull on steroids.
The last America's Cup in the AC50s was really exciting racing, but the yachts were very, very similar to each other. And I think the class we've gone to with the AC75, it really allows us to sort of keep up that momentum of really high speed, high performance, exciting boats, but also go off in a new direction and do something completely different.
To start with, it's big, 75 feet long, 16 feet wide. But it's also light, which is crucial because the AC75 is designed to fly. And it's different. Rather than a keel, a brand new concept keeps it standing. Foil cant arms move under or outside the boat to provide the leverage it needs to stay upright.
When we developed the class rule, we really wanted it to be quite open. So designers have a much bigger area in which to play. We wanted to allow space for innovation and space for different teams to design different hull shapes, different ways of controlling the sails, different foils and rudders.
The challenge obviously is that it is completely new, so there was no one has ever seen such a boat on the water. There was no experience. We could not build on something existing. It's not only a new rule, it's a new type of boat that the world has not seen before.
What we tried to achieve was a boat that really can surpass the past America's Cup boat as technology. And to beat a multi-hull, it's a pretty tough challenge to do. But as a concept, it was a challenging design. And to get it right, we haven't seen anything like that before in the history of yachting, of sailing. So that was one of the main challenges.
It was a risk that we took. We developed the class, wrote the rule, and everyone embarked on building these AC75 yachts when there'd been no prototype. So everything that we developed in the class was through simulation.
Parts of the boat are supplied. The mast, rigging, foil cant arms and their hydraulics are all stock components. But there are still plenty of areas that designers can experiment with to find a race-winning edge.
There is lots of free thinking in this rule, and it was done on purpose actually when we worked on the rules. So the design space is really big. That gives plenty of opportunity for thinking out of the box. The best proof for that is that we see now 4 boats out there, and the 4 boats look very different.
One of the biggest differences I think we've seen thus far is the differences in hull design. That's probably the most largely talked about item of the 4 boats that are out on the water at the moment. Every team has taken a slightly different approach to the same problem.
So I would say there's on one side American Magic and Ineos. They have pretty flat hulls. And then there's Team New Zealand and us. We have these hulls with a hump at the bottom. That shows that we had quite different ideas on how the boats will be sailed.
One of the fundamental decisions you've got to make is whether the crew are going to transfer from windward to leeward through a tack or a jibe. It's a really interesting sort of design trade-off there of whether you move the crew or keep them fixed. We'll find out who's got it right and who's got it wrong.
A new evolution is the twin skin mainsail. The double sail skins combine with the spar to form a wing, generating the power the AC75 needs to foil.
A sail is effectively a wing that stands vertically. So instead of just a single mainsail that a conventional yacht has, we've got a twin or double-skinned mainsail, which gives a really efficient aerodynamic section. If you took a cut through that, it would look like a D section at the front with the 2 skins coming aft, much the same as an aircraft wing.
Underwater is where things get really interesting this America's Cup, but the story starts inside the boat. The foil cant system is brand new technology, a battery-driven hydraulic power unit that supplies the energy to lift and lower the immensely strong and heavy foil cant arms. As the boat swaps tacks, the cant system is activated, placing one hydrofoil in the water and lifting the other one out, where its weight becomes ballast. At the end of the arms lie the team's secret weapons, the foil wings. Apart from basic rules governing dimensions and weight, these are open territory for designers.
Foils could well be the area which decides the next America's Cup. The principles which allow an AC75 yacht to foil are basically the same principles that allows an aeroplane to stay in the air. So we've got an airfoil section on the foils, which is roughly the same cross-sectional shape as an aircraft wing, and the flow over the top of those foils is faster than the flow underneath due to the geometry of the section shape. That creates more pressure underneath, which lifts the 7.5 tons of the yacht and her crew.
A new advancement this Cup, the foil wings have trailing edge flaps, just like on a plane, providing extra lift on takeoff and giving the crews precise control over ride height.
So for the foils, we decided to allow flaps on their trailing edges, which are much the same as ailerons or flaps on an aircraft, which can rotate to control the amount of lift, but ultimately it allows you more precise control of the lift and therefore the ability to fly.
The AC75 is one of the most radical design challenges ever presented to teams in the America's Cup, breaking new ground in design and technology, enduring hallmarks of 170 years of America's Cup competition.